Good evening, my dear students. So today we will talk about electric potential difference. So this is actually our first topic on current or dynamic electricity. So remember that the last topics that we talk about is about static electricity, diba? So in those topics, we consider the charges, or the charges are actually at rest. So of course there are some movement, like for example, when charges will distribute themselves uniformly in the surface of a conductor, but diba they stay in that position, in that equilibrium position. But in current electricity or dynamic electricity, the current is always moving. Like for example, they are flowing continuously through or along the wire. So I think this is a good start to talk about that, because in this module we will talk about the reason why the charges are capable of moving from one end of the circuit to the other. Okay, so let's go to the first part: electric field and the movement of charge. Discuss what happens to the potential energy of a charged particle if it is moved in the direction of the electric field. So does it increase or decrease in potential energy if it is moved closer or farther away from the source of the electric field? But before we do that, let's connect it to something that we already know. Okay? So dito may dalawang situation. And the first situation letter A, you can see that the object is free falling from a certain height towards the ground or to the ground. Meanwhile, in situation B, nung una, nasa ground yung object, diba? And then you applied force or you do work on the object para siya ay mapataas to a certain height, nakapantay noong nasa scenario A. Makita mo din na nakalabel na high PE, low PE, ibig sabihin potential energy, yung dalawang height. Yung malapit na sa ground or nasa ground na, that's the low potential energy location. Meanwhile, yung nasa taas ay yung high potential energy situation. Okay, you also notice that hindi mo kailangang mag-apply ng external force, diba, to do the work para mag-free fall yung object na yon. When you release the object from a certain height, it will naturally go down. Okay? So its journey was from a higher potential energy to a lower potential energy. By the way, bakit natin nasabi na high potential energy yon? This height? Because syempre, diba, from this formula, height is a factor, have a direct relationship with potential energy. So, in the situation letter A, the motion of the object is natural, di ba? Sabi nga ay, all high things must come down. So, when you release it from the certain height, you don't have to do anything. Gravity will do the work for you, di ba? So, it's a natural motion. But it's a different story on situation letter B. Kasi in situation letter B, kailangan mo talaga mag-apply ng force para maangat mo yung mga objects, as we all know, diba? So if you go against the gravitational field, if you go against nature, you have to put in some work or apply an external force to do the work on the object. The journey of the object in this case is from low potential energy to high potential energy. So saan ang galing yung potential energy na nakuha niya? From the work done. Okay? The object that did the work transferred potential energy to this particular object. So, objects naturally move from high potential energy to low potential energy under the influence of gravity. Work must be done by an external force to move an object against nature from low potential energy to high potential energy. Now, let's relate that to electric field and to current electricity. So, again, we have two diagrams A and B. So, you have a positive source charge. That means na away yung kanya electric field, right? And then you have a test charge, the smaller one. So, in diagram A, you will have to move the charge na nakalocate at A to B, so closer. Meanwhile, in the other one, you have to move the charge at point B to A. So, try to remember our analogy a while ago. Alin sa dalawang diagram yung will naturally happen. What I mean is, hindi mo kailangan mag-apply ng work to make it happen. Is it the scenario at diagram A or is it the scenario at diagram B? So of course, you need to apply work from an external force doon sa diagram A. Kasi diba, you will be going against electric field. Naturally, the positive test charge will feel repelled, diba? By the source charge, by the positive source charge. Kapag pinasok niya yung electric field ng source charge na to, makaramdam siya ng repulsive force. So naturally, it will move away. So kailangan mo mag-apply ng work para siya ay mapalapit from point A to point B to make it closer to the source or make it go against the electric field. Meanwhile, sa letter B, ilalayo mo na yung object, diba? From the source of the electric field. So actually, you don't have to do anything because the test charge will naturally move away from the source charge as it is experiencing a repulsive force. Okay? So, yung diagram A is similar to lifting objects from the ground. Meanwhile, diagram B is similar to letting an object free fall from a certain height to the ground. So, saan nagigain ng energy yung iyong test charge? Of course, on diagram A. Because when you do work on an object, the energy will be transferred to that object. So, magigain ng potential energy yung situation A sa situation A and maglo-lose naman dito sa situation letter B or diagram letter B. Work must be done by an external force to move the positive charge against the direction of the electric field. It gains electric PE, potential energy. Meanwhile, in diagram B, the positive charge will naturally move in the direction of the electric field. It loses electrical potential energy. Okay, the situation will be reversed when we're talking about or when we have a negative source charge. Remember, electric field is towards negative sources. But you still have a positive test charge, diba? So diagram C, you have to move it closer. Diagram D, you have to move it farther away. So imagine if you were the test charge, the positive test charge. When you enter the field, you will feel an attractive force. So you are drawn to the negative source charge. So on diagram C, definitely you don't have to apply work on this one because the test charge will naturally move towards point B or towards the source. But to separate the test charge from the source charge, that's the time that you will apply work, diba? And that work will give it electric potential energy. So diagram C, the negative charge will naturally move in the direction of the electric field. It loses electric potential energy. Meanwhile, on diagram D, work must be done by an external force to move the negative charge against the direction of the electric field. It gains potential energy. So in the same way as the previous analogy, it is natural motion if objects are going from high to low, high potential energy to low potential energy positions, such as the discussed scenarios. Okay, I'll see you on the next one.